This video is about the Vortex Tube. That's a device that separates air, compressed air, into a warm stream and a cold stream, and it does it in an interesting way related to physical chemistry. So what happens in the Vortex Tube? The air comes in on the outside, and there's a special nozzle that points it in a spiral towards the back. So it spirals around the outside of the tube towards the back, and then there's an interesting device here that folds the flow back on itself inside, and it spirals back down the inside of the tube to the front, where one stream is let out of the front. On the outside of here there's a little gap where some of the air can pass out. The engineering explanation of how this works is that the vortex on the outside, the air moving around the outside, is moving at a certain rotational angular momentum and a certain rotational speed, and the air moving down the inside has got the same speed. So when it goes when it goes from the outside to the inside, like a dancer speeding up, or like somebody who spins around and pulls their arms in quickly, it should, by conservation of energy, it should spin faster, but then it would be spinning faster than the air on the outside. So there is a mismatch between the two requirements. One is the conservation of momentum, the other one is the conservation of energy. And to get around this, the air on the inside transfers energy to the air on the outside, which then gets warmer. The air on the inside gets colder. That separates the energy, and if we let some air out here and some air out here, we can have slightly warmer air and slightly colder air. The force is the pressure, the difference in pressure between the inside and the outside, multiplied by the area of the piston, and the work done is the force times the distance. So F dot x, where this is x and the area of the piston is depending on what shape it is. So that would be the engineering explanation. We've done some work on it. That must be some energy. It's increased in energy, and therefore there's a temperature gain. If we do it in a statistical way, we can imagine that we have some molecules in here and they're moving around, and if we push it down at some speed, a molecule hitting this face will come back at a slightly higher speed than it would if it hits one of the faces that is not moving relative to the gas. And therefore we get again an increase in temperature because the average speed of all of the molecules inside has gone up. In both the Earth and the centrifugal vortex tube, we have a low energy down at the bottom and a force, which in this case is gravity. Let's have small g for that. And we have a force here, which is the rotational torque, the centrifugal acceleration. So this would be mg, and this would be the mass for the particle also. And we have a particle here. If it tries to move up, it's got some heat and it happens to be going upwards. It is moving up, but it's moving up against a force of gravity, and so it slows down. Obviously the speed of molecules is very high compared to the forces here involved, but the distances in gravity is very long. In this case it's a comparatively high force, and we're not getting a huge temperature difference. So we have a particle, it's moving against a potential energy gradient. It loses energy, it slows down. In this case it slows down because it's moving up towards the center of the tube against centrifugal acceleration, in this case against gravity. When it gets to the upper atmosphere, it has very little energy left, it's cold, and then it tends to fall back down again. In this case it has little energy left, and it falls out of the end as cold air. So how does this all apply to vortex tubes? Well, we can imagine that if we have a molecule down here and it has to make its way to here, it is effectively moving from a low potential energy where it's on the outside being flung out by centrifugal force. It has to gain some centripetal acceleration to move inside. So let's have a look at one of these. Here's mine, it's just coming up, here it is. The tube in my hand is where the gas is going to go in. It will go on this gas tap here to compressed air. The metal body is where the vortex goes down and back. The blue part on the left is the outlet for the cold air down from the center. The bit where I was pointing is the outlet for the hot air on the outside. The knobbly metal part is where the vortex is generated. Here it is in infrared. You can see that the tube is exactly the same temperature as the background. The hot end of the tube is getting up to 30-ish degrees, and the cold end of the tube, which is plastic, cooled down from the temperature of my hand, about 25-30 degrees, down to, it'll eventually get down to about 8 degrees. This is, by the way, a bit sped up because it takes a while for the temperature to equilibrate. So there it is, the vortex tube, a device that uses the energy in compressed air to generate a warm and a cold stream of air without any moving parts at all.